let's get into AC machine fundamentals. Now, some of this stuff is not explicitly stated in the handbook, but is important for understanding the concepts. These formulas. I'm not expecting you to, try to memorize anything that's not there, but you do have to remember, the mechanics of how these machines operate. So we're going to be talking about cross products, vectors, and things like that, which gives you an idea of the torsional forces developed, and that's all important, to understand how these work. So we'll start off by talking about Faraday's law. Pretty simple. Talks about an induced voltage across wires. If you have a number of coils wrapped around a magnetic circuit where you have a flux or magnetic flux that changes with time. And the equation that governs that, Faraday came up with it. It's induced voltage is equal to minus N times the rate of change of flux with respect to time. Now we know that an inductor in a DC circuit looks like a short circuit. That's because there's no changing flux. Once that magnetic field gets built up, that flux is constant. There's no more voltage dropped across that inductor. But there is definitely a magnetic field there, and there's definitely energy stored inside that inductor. E is voltage, Mike. That would be the voltage across. Let me spread this out a little bit and get my drawing tool up. That would be the induced voltage here. E induced. So basically what it's saying is as this flux changes with time, it induces a voltage, and the polarity of that voltage is such that it will induce a flux, phi induced, that opposes the changing flux that produced the voltage. Now we know that from V is equal to L di dt, which just defines the voltage of an inductor across an inductor. That inductors don't like a changing current. In other words, if you have a delta I in 0 time, so if delta T is 0, then that voltage becomes infinite. So they don't like changing current. They want that flux to remain constant. That's why the induced flux is opposing the changing flux. So that's Faraday's law. Just all you got to remember here is that a changing flux, magnetic flux, will induce a voltage, and it goes in proportion to the number of turns of wire, and that becomes important when we talk also about transformers.